Okay, welcome to week 4 of Python. So to begin with, let's see, we have a couple more people here. Welcome. So to begin with, how is everyone's Python going so far? Is there any unexpected challenges? Nothing is still working fine. And okay, let's see. And type in the chat if you already have pandas installed on your on your personal laptop, because you will need to do that for this week and the weeks below. Like there's a lot of assignments that you will need to use pandas, etc. with those. And you will also need to use Jupyter Notebook sometimes in the course. So just want to make sure everyone is comfortable with both pandas and Jupyter Notebook. Does anyone have any problems setting up those things on your laptop? Pandas, Jupyter Notebook, any of the dependency issues when you're installing pandas, you say, oh, wait, there's an error, something like you're not in the right version of whatever, like NumPy or C Python or whatever. Does anyone got those messages when you were installing it, where everyone's installation was just perfect? Type in the chat if you're saying your installation is perfect. Everyone seems.
You said pandas and what else?
Jupyter.
Jupyter?
Yes.
No, I haven't installed it yet.
Because, well, here's the thing. You could, technically speaking, run all the Jupyter in Google Colab, or in the next week, we are going to see a Kaggle notebook. They're both they're basically the same notebook environment I'm using for a lot of the demo so far. Let me share my screen. Like you could create your own account and run the code with pandas and Jupyter. Well, this is what we call the Jupyter notebook environment. It's basically in a Python package that allows you to code and see the result immediately, kind of. And it's also supported a lot of the plotting utility and so on. But the problem is, you will need to install this on your computer. Otherwise, it's not native. I'm not sure if your VS Code has this built in. Maybe it does. So it does depend a little bit on your version, but you will need to install a package called Jupyter, and it might cause some problem when you're trying to run it locally. If you don't, if you haven't, I think you should try to install that. I mean, you could always just run the things on Google Colab Notebook. The problem is, whatever you run, you have to start from beginning. Like, oh, I run this 2 hours ago. Can I still run the next step? The answer is no, because your connection is lost. That being said, I think there is some good thing about Google Colab is that it's the easiest way you can start working with, has anyone heard about, has anyone heard about NVIDIA and GPU and so on? Heard about that, but never, can anyone tell me what is that? Or you just heard about it, but never really know what are those things? Or you heard about it, I think that's a gaming thing. Anyone? Nope, never heard of NVIDIA so far. Anyway, NVIDIA, if you're willing, well, you can change the runtime type here and use some of the NVIDIA GPU. I think A100 is one of the GPU offered by NVIDIA. That's the easiest way you can start working with resource-intensive data computing. But you might need to pay $15, $20 a month or something. It's a different story that we'll need to worry about after this Python 100. So cool. Welcome everyone to Python 100. So today we're going to see some more examples with data engineering and pandas. So first thing, what is data engineering? Well, it's basically a subset of software engineering that specializes in data transformation, extraction, and storage management. Like imagine, let's say, YouTube. YouTube probably has billions of videos and users online each day. And they have petabytes of data, which means thousands or millions of gigabytes of data per day. uploading and downloading, how could we manage all this data efficiently? That requires a different set of skills and architecture to work with. Like when you're working maybe with React or with your like backend and maybe Node.js, you don't really, your data transformation usually isn't a problem. Like maybe you're just sending a few megabytes or like kilobytes of data between your front end and back end. That's usually fine with modern computer. But when you're uploading like gigabytes of data, you will need something a little bit different. Okay, and it also works. It's also like a field that's supporting a lot of the like data analysis. Like for example, maybe a lot of you have worked with Excel and manipulating data with Excel. And what if we can write programs to automate those processes, like extracting what is the weekly sale or whatsoever in Excel and make it more like powerful, make something like more meaningful, and then just copy pasting and run the formulas in Excel and automated this process in full. That is what data engineering is working. Like building extraction, transform, and load pipeline, and building like dashboards. Like for example, you see those stock price, like most recent prices, the historic prices. Those are what we call the dashboards, and trying to transform our data into machine readable formats. For example, deep. I think everyone has used ChatGPT before. So how does ChatGPT comprehend our language? Do they just read it like Alice, Bob, Shirley, Lynn, Christian? Is Tatiana, is that how it works? Well, no. Deep under the hood, there is some computer algorithm that is basically translating what is data we have, like a string, into like a series of numbers that ChatGPT can read. And if you use the wrong method, this process could take 10 times longer. Like, yes, you can try to like download ChatGPT on your local computer and run it. You'll realize OpenAI actually does a pretty good job like optimizing the response from ChatGPT. Actually, you can run a mini version of ChatGPT on your local laptop and see how long does it take to generate a sentence. It might take like a bit of time if your computer is not configured properly or you're not using the right method. That being said, today we're going to start with data wrangling with Python. So previously we've seen like dictionary, list, string, and basic data structure, and we've been like, I mean, we could just wrangle the data with that, right? Why do we need a different set of skills or packages? Well, technically, yes, you can always like you can run all of the tasks we cover today with list, dictionary, set, and string, and other integer and basic data structure, but your code will run 10 times slower. And we're going to see one example of that. Why is it 10 times slower? And these packages are created for a reason. They will simplify the number of lines of code you will need to write. So this is, if you're, well, I mean, you could always try. It's a good exercise to practice programming, but that's probably you will want to kill yourself happily. And there are a lot of different packages like Koala, NumPy, etc., Pandas that's created for this job. Today, in this Python 100, we're going to focus on Pandas. But if you're ever going into machine learning or something different, or like scientific computing, NumPy is the go-to option. Actually, a lot of the Pandas packages are built upon NumPy. Okay, Koala, you might not need that unless you're working with some larger data sets. Okay, so we're going to start with the basic of Pandas concept. So for Pandas, here's basic summary of that. We have a data frame. You can think about like a data frame as a spreadsheet or like two-dimensional array. Fundamentally, I think it's easier to think about it as a tabular spreadsheet. Like, let me open my Excel and show you a little bit. I think raise your hand if you have not used Excel or type in the chat. Has anyone know what I'm talking about is with Excel or like those, or numbers if you're using Mac or whatsoever? So one way to think about the Python NumPy data frame, Pandas data frame, is to think about it as, okay, it's basically Panda is reading it like each of the thing in one of the column, that is your column, like column 1, column 2, column 3, column 4, and the inside is storing all the things here. So it's really a Python way of reading your spreadsheet data, really. Okay? And actually, it can also support a lot of the files you're working with Excel. For example, you can save your Excel file as an XLSX format file, and you can also read and work with those things in pandas. So a series is basically one of the column data in Excel. So if you're experienced working with Excel, you know you can copy that around. You can do some like formula operation with that. And that's exactly what we're doing programmatically in Python. An index is basically the row number for each of the data. That's the easiest way to think about it. And we also have columns. Basically, like the header, like column 1, column 2, or in different settings, it could be the sales of this season 1, season 2 sale, week 1, week 2, week 3, week 4, week 5. And the shape, I mean, if you have 5 columns by 6 rows, then that's a 5 by 6. And these are all the methods you can call. And we're going to worry about selecting and indexing a little bit later. But here is one of the series examples. You can create, basically, you can also think about a series as a fancier version of list. And we already know how to work with list. So here's an example that we're creating a pandas series with a list. And if we run it, we can also access that by the index. Nothing special. And you can also run minimum of this scores. Or you can, this one also support this method, the min. In principle, using this method is faster than running a function. This is a faster one. All right, let me type it here. This is a faster one. This is a slower one. Most of the time, it doesn't really make a difference unless you may have like a million data. But in principle, this method will be faster than this method because pandas is also created to optimize a lot of the Python operations. So for those of you who want to go deeper, you can look into something like C Python. But basically, a lot of the pandas packages comes in with built-in optimization. So if you can use a built-in pandas method, do not write your own method for that. Try to go with the built-in method instead of using the like whatever function you're writing, because chances are whatever you're writing will be slower. Okay, and there are different things we might talk about later. Oh, I think this is supposed to go here. Yes. All right. Similarly, we can use like, remember last time we talked about whenever you're having a class, you can call this double under dictionary method to see what's the attribute of that. And now a series is also a class. So here we're actually just instantiating a class with this like constructor method. This is the constructor method for this series class. And now let's see what's happening here. We have a range index, which basically just say, okay, you can go from 0 to start at 4, basically the basic like Python like list operation indexing. But there's something more interesting. Oh, we have a data type, int 64, and item cache, whatever. Can anyone tell me what is int 64 in the chat or just speak it out? Anyone?
I guess it's data in integer.
Correct.
Data integer type.
Great. So for those of you who might work with like JavaScript or some other languages before, you might know, oh, there's an integer type that's 64 bits. Previously, we say that in Python, like we don't really have this to worry about this, right? But it's kind of a lie. to be honest. Well, when you're working with some of the packages, you do need to worry about it. And in this case, if you're, let's try to do this. Let's try to do this. So let's try to change score of 0 into a very large number. Can I really do this? What would happen? Can anyone make a guess? This is clearly beyond the integer 64 bits. What would happen? Let's see. I'm getting a key error, a value error. Why? Because this is larger than what an integer 64 bits can take. This error will not happen with a Python list, but it will happen with a pandas like series or pandas data frame. Whenever you're inserting something with a wrong data type into it. For example, if I try to say something like this, this is allowed, yes, but it's giving you a warning of that. Okay, so it's in principle, pandas allows you to insert like whatever data into it, as long as whatever you're inserting into it is not too large. By too large, I mean the data is not too large. Like it's smaller than 64 bytes in this example. So you do need to start thinking about what is the data type here and what might cause some of the errors when you're working with pandas. And also the integer 64 is not the only data type. You have float 64, you have int 8 if you want to ever use that. So please be careful when you're working with like the data type. It will cause a lot of errors at the end. Okay. Why is this example still here? Okay, yes. Now let's see one example with this pandas data frame. This is an example data frame we're creating. We're basically creating one. So here, let's try to break it down what's happening. So here, we're creating my dict. This is a dictionary, right? We're creating a dictionary with that. And now we're fitting this dictionary into this data frame. Hold on. And it seems fine. I created that. But when I'm trying to do this edit by one error, it's giving me an error. Why? I mean, I can display this data frame. Yes, it's created as expected. Everything looks fine. And I'm just trying to create an ID plus one column. What is wrong here? Can anyone
Is
tell
the
me how can I fix that?
okay? Is that ID immutable?
ID immutable? Well, immutable. Let's try. If it's immutable, then I can try ID into 1, 2, 3, 4. This actually works fine. It's actually mutable, right? This is my new data frame. It's actually mutable. I can actually change that. So it's probably not because it's not mutable. There's something else that's wrong here. Anyone else? The type error is telling us I can only concatenate string to string. What does that mean?
There's a mismatch in type.
The type is not matching. So how can I fix that? What if I really want to be 102, 103, 104, 105?
So you cast one of the type into the other type.
Great. In pandas, this is one way you can do it. Hold on. String not integer to. Hold on. Concatenate string. Okay, this doesn't work. I think you need to do is df of ID instead of right type. This would work. Huh. Strong or just so basically this is one way to do it. Initially you need to test that. Well, there is a type casting function. Hold on, let me think about what is the right way to do this type casting. Can only concatenate into. Oh, because sorry, I forget this is not an in-place operation. Now this works. Df ID plus 1. I'm not displaying the right df, sorry. Yes. And notice the pitfall I was falling into. I thought, oh, I'm using this function to cast that, right? But this casted series is not converted, well, it's not assigned back into my original series. This is because this operation is not an in-place operation. This operation is creating a new series that's an integer type of my ID, but I'm not assigning it back into my ID. And that is also a very common Python mistake I make, even though I've been using it for 4, 5, 6 years. Okay, so be careful with this type of errors. I still make these errors all the time. Okay, now we are also going to talk about a little bit about indexing and slicing. So here, there's two primary methods we can select items in like type in pandas. One way is with the location method. So location method is really just you're trying to access the value with the index. Notice that okay, the index is not right. I don't really have this data frame anymore. Let's see. Location, let's try to locate. So here, notice that this column 0, 1, 2, 3 is the index of my data frame. This is the index, basically the row number. And the column, this is what sometimes I'm using as a data science person, I'm using feature and column kind of interchangeably. So whenever I'm saying feature, sometimes I really mean column. One of the column is score, one of the column is ID. So one of the way I can access that is by assigning, okay, I'm assigning the 0th index in the score, and this should really give me 90. Right? And I can also do similar thing because, well, this is the first element in the first one, right? Notice that we're in a two-dimensional array. This is the 0th row, and this is the first column. I'm using it. So this is also giving me the, it's 0th indexed. So this is the 0th row, and this is the 1, 0, 1. So this is the y value, the y position is 1. Well, the column position is 1. The row position is 0. Similarly, 85. Can anyone tell me how can I access 85 with index location method? Anyone?
One,
I checked
one,
only 1 to 2. Sorry.
1, 1, because it's the first row and the first column. Remember, it's 0 indexed. Okay? In Python, it is 0 indexed. If you ever have the pleasure to work with some other languages, it might not be. You need to think about which language you're working with. Most of the programming languages 0 index, but some of them, the more annoying ones, are not. But they are common in data science. Like if you ever have to work with R or MATLAB, they are 1 index language for whatever reason I don't understand. But most of the time, Python is 0 indexed. So this is one way, 2 different ways you can access that. Another primary method you're going to interact with is trying to call df of score, which is equivalent to df dot score. Okay, I'm not displaying them. And by the way, for most of the cases, if you're ever displaying a series of data frames, display method will work better with than print method in the Jupyter notebook. We'll see why. Because if you run print, sometimes the format would be off. That being said, you need additional packages to use the display method. So it's a little bit more extra work for better visualization. So far, so good? Okay, now we're going to see a little bit more interesting operations with that. So here I'm using the iris dataset. It's a very popular, famous, I don't know, popular, famous, simple dataset for like illustrative purposes of data science. You can download this dataset in the link I posted. And if you want to run it in Google Jupyter Notebook, you will need to upload that into this folder. Just drag it into this folder and you will see it here. That means you can start using it. And if you're working with your local directory, you will need to open it in the right way. Let me open it with Excel so that we can all see what's happening here. So here's what I'm doing with Excel. I'm opening it up. You can see it here. Fundamentally, well, you can also open the CSV with a text edit. And you can actually see why it's called a comma separated format. So you can see this is each of the, and this is the result of Excel. Fortunately, I can't share two screens at the same time. Basically, this is a small data set with 150 data points. It's 151 because of the header here. And then each of them, you have the species, and you have 4 different measurements from that species. Let me open it in a different setting. Where is it? Where's the screen? Here's the same document with text edit. A lot of the time, if your document cannot be opened with Excel or when you open it with Excel or read it with Pandas and you see it's giving you an error, try to check with text edit. Because sometimes, I mean, in the learning materials, we've learned that, even though it's called CSV, most of the time it's separated by comma, right? But sometimes some people prefer to separate it with a separator, like this. And in those cases, if you open it with a Pandas or Excel, without telling those programs you're separating them into something different, you'll get an error. That is a very common thing to happen. So this is the comma separated file. It carries the same information. And now I'm going to share back to my, nope. Okay, this is what we're going to play with. Here, I'm displaying some of the information out here. If you use df.info, you're going to see, okay, what's the columns here and how many non-null counts here. Non-null count means that, okay, there is something in a data set. There's nothing missing. In data science and data engineering, if you have something missing, that's usually a problem because if you have too many missing things, that means your data is useless. If you have too many missing things, that might also cause bugs in your program later. We're not going to worry about this until next week. For this week, I don't think you need to worry about the missing data. Wait, actually you do with forward filling and backward filling. But, well, okay, let's say we should start thinking about how to fill in the missing data. So, and you can also see the data type for each of them. The species is called an object. Yes, if it's an object, that means Pandas doesn't really know what is the right data type for this column. It could also mean there's 2 or more things in the 2 or more, 2, 3, 4 or more different types of data mixing inside this column. So that is something you probably want to worry about, but in this case, we know it's all string, so I can just convert, actually I should convert it into string. Df all species. This is the most common way to do typecasting is dot type. No, not well. You can do it with category, but this time I'm doing with string. And yeah, it's still telling me it's an object, but I think that's okay. Okay, and you can use, and then the head will tell you the first 5 rows of that. One good thing about Google Colab is that it supports some built-in like automated data visualization. You can start plotting it, even though the plot is usually crappy. Something like that. Yes, you can. It will automatically generate some of the plots for you, but they're kind of crappy, so I never really used them. Anyway, now the last feature is df.describe. It will tell you, okay, first the count, how many data are in this data set in each column. I think it will only include the non-null count. What is the mean if it's a numeric value? So this is kind of like high school or intro to statistics math. The mean is the average of everything, like your class average. I think most of people have heard about this before. The standard deviation is a little bit more involved statistical concept. The minimum value of this data set in this feature of this column, like the smallest sample length is 4.3, and this is the percentile score. This is what we call the Q1, and this 50 percentile is also called the median. We're not going too much into the statistics part. If you're interested, if you're really interested in going into data science, this is something you should know. And then, of course, the maximum value. Great. Now we have some basic idea about the data. With pandas, you can also do some. Well, pandas also supports some basic like data visualization. For example, you can plot a histogram, you can plot a bar chart, etc., with that. Next week or 2 weeks later, you're going to see one task called data visualization. And as a side warning, pandas data visualization is not the best one. It only supports the basic one. There are better packages for data visualization where you can do like animation, where you can do like interactive plots. We'll work with those later. Okay, so cool. We have seen some basic operations with the data frame. Now I'm going to show you 2 examples. Well, I've already run this. So here I'm copying this data sets, the iris data sets, and I'm trying to calculate the sample area. I think the sample area is basically one of this, the petals area, if you have seen iris flower. So the sample area is estimated by the sample length times the sample width. So this is what I'm creating here. Now, this is what we call the vectorized operation, which means that we're using this array, multiplying that with this array, element by element, okay? And creating that as a new final result. As you can see, it takes around 400 microseconds. Now, here we have the same operation. Notice how long does it take? 2.6. Oh, sorry, this is microsecond, this is millisecond. Millisecond. For those of you who doesn't really know what's happening, who doesn't really know this unit, this is about 2,600 microsecond. So this one is like 8 times slower than this operation when you're writing your own loop. This is one good reason you should stick with vectorized operation. For this small data set, I mean, it's microsecond versus millisecond. It doesn't really matter. But when you have millions of data, it does. Okay? And notice one thing. Some of you might have noticed, oh, why is there a deep equals to true? Do I always need to do this call? And what is df.copy? Is df.copy different from df, just equal to df? Can anyone try to make an educated guess about what is df.copy deep equals to true is doing? And why do I need that? Anyone? Anyone? Okay, Amir, go ahead.
Hello, can you hear me?
Yes.
I think that deep copies are what you would traditionally have in C-based languages. It's referring directly to the data itself, whereas a shallow copy would refer to a pointer to a memory. So if we set deep equals true, it gets the data itself. And if we modify the temp variable, it doesn't change the df variable itself because it's a copy of the initial data. But if we say temp equals df, it will have the same memory address as df. And then if we modify temp, df would also be modified. The reason we don't want these two to affect each other is because when we're going over like for I in range, and then we do something with the area, we don't want our original data to be affected.
Great. This is exactly what's happening and what we're going to see in further details in this example. So remember what our DF look like now. Okay, this is, I have sepal length, sepal width, petal length, petal width, and species and ID columns. And now I'm calling this new DF equals to DF. DF new equals to DF. This is basically the same as dot copy and deep equals to false. Most of the time we just write this if we want to show a copy. Now, notice that I'm dropping one of the column here. I don't really need that in my new DF for whatever reason. And it's as expected, right? I'm missing one column. But what would happen to my DF if I display it here is that it's also dropped my original DF. And this could be problematic, especially when I have maybe like 100 different operations afterwards. And I don't necessarily want to modify my original data. In fact, one of the principles in data science is that you should always keep your source data intact. When you're doing a new data, you should try to make sure it's recoverable. You don't really want to modify the original data. So the better way to do it here is actually switching to this. This is what we want. And now, because I already tempered the data, I will need to read it from the source again to actually make sure it's not tempered. Okay, this could cause a lot of problem. And also notice that this is not a data frame only problem. We didn't quite cover this, but this is also a problem with your list operation. Here, I'm trying to create a 2D list, original array, and this is a shallow copy. Hold on, I'm only changing a shallow copy. Why is my original array also tempered? Well, because that's a deep copy. Oh, sorry, that's a shallow copy. So please make sure this thing keeps like lies in your mind sometimes when you're debugging something like unexpected changes to your data. This could be one of the most likely reasons. Okay, now pandas also offers a lot of conditional operators. Instead of like, you can think about, oh, if, else, and, or equal, something like that. But they are really different from like standard Python operator. Okay, in pandas operators, conditional operators, you do not write double equal. You do not write like, sorry, you do not write and, you do not write like, or. I think I'm missing that here, sorry. How am I missing that here? Okay, I think I'm missing part of the table here. But here's the thing, the pandas operator is a little bit different from our Python operator. Let me create a new column. So I want to create, let's see. I have my sepal length. I have, let's see, df.describe. Okay, what if I only want the sepal length, the species that's Iris setosa. Okay, I only want Iris setosa whose sepal length is between 25% and 75% percentile score. How can I do that? Well, I can run my new df equals to df of Iris. You can do this Iris setosa. Oh, this one is so useless. Equals to Iris setosa. Hopefully this is the right one. Okay. Yes, Iris setosa. And let's try to do it this way. This is how you would normally write conditional operators in Python, right? And I want it to be the sepal length to be greater than my 25 percentile score. So let's try. df.sepal length is greater than 5.1 and df.sepal length cm is greater than, smaller than, I want it to be between 25 and 75 percentile score, and 6.4. Will this work? Let's see. It doesn't. Why is it telling me ambiguous? Well, one of the reasons is because I'm not supposed to use this operator. I'm supposed to use this logical AND operator. And I'm supposed to break it this. This is more like a C operator than a Python operator. Okay, and now this is what we found. This is the filtered result. So the major difference, I should add that into this table. I don't know why it's not here. Bad. Is that instead of and or, you use this for and, you use this like bit and for and. If you remember, this is one of the bit operator, and bit or for or. Does that make sense? Cool. Now let's move on to a more challenging task for today. So our target for today, our final target for today is to create a new data frame that contains the following columns: the species, the sepal length z-score, sepal width z-score, petal length z-score, and petal width z-score. Basically, what we're trying to do is to normalize the data sets by its species. So basically speaking, what we're trying to do is to find the standard deviation, which we kind of already have. Remember from this one, for each one, we have the standard deviation, right? And we also have the mean for each of the features. Great. But that's not based on the species. What I want is, okay, for each species, find the standard deviation of that species and find of that feature in that species. For example, for Iris setosa, the standard deviation for sepal length is 1.5. And the mean for standard deviation for Iris setosa is also 1.5. And then once I have these two data sets, two information, I can create a z-score based on that species. Okay, in case you guys are super confused about that, I do have an example. So here I'm separating Iris setosa. I know, okay, the Iris setosa has a standard deviation of 3 point something like this, and then mean value, the average value of 5.506. Great, I'm creating that. And now I can do something like, okay, this is one of the standard deviation for Iris setosa. Actually, I could just do df.species equals to Iris setosa. Aristotosa. And now this is one part of the result. This is what we call the z-score for Aristotosa, for Aristotosa's sepal. So what we're trying to find is the sepal z-score for Aristotosa or Iris. You can kind of just replicate this process by 6 times, or there's an easier way to think about is using the group by operation here. I'll leave it up here. I think this is enough hint. I'm going to send you guys into breakout room. I think how many people do we have? I have 11 people, so I think that would be 3 breakout rooms. And see if any one of you can actually find your final result. So this is part of the result. You can just keep going and just concatenate all the data like this, or you can do something different with group by and transform. Okay, I think that's enough hint. I'm going to send you guys in your breakout rooms. I'm going to create 3 breakout rooms. So 3, 3, 4 people, 4, 4, 3 people. Okay. Okay, the breakout room is open. We'll be back in around 10-15 minutes to see if anyone can tell us the answers. How do I do this? For those of you who are still in the main session, you should go to the breakout room. If you're not seeing it, it should be popping up. You should just click join the breakout room. We have 2 more people in the main room. Are you having any problem going to the breakout rooms?
excuse me, David, we don't have access to the main code that we were practicing here.
Oh,
And the
does it?
breakout room, we cannot do something. Sorry.
You can't, wait, I think you can, you mean you can't see it or can't download it?
Yes, we can see it there.
Huh. I'm supposed to get access. I think you can just open this file and just work there, right?
All
This
right. How can I access back to room 3?
hold on. How can I move you to the room 3? Good question. Fortunately, I don't know how to move you to room 3 as well.
Yeah, no problem. But room 3, they were just waiting because we didn't have access to the main code. Yeah.
Okay, I see the problem. I think you should be able to just open the file I posted in Slack and then see the problem. Okay, I'm going to close the room and see if that's causing problem for everyone. Okay, does people have problem viewing the problems I posted? I wasn't aware of that. Basically, you're supposed to be able to see the same set of problems in the, like, using the link I posted in today's session, before today's session, and work with the data there. So anyway, does anyone have any ideas about how to actually do this in any way? Anyone? Any thoughts? How can I actually finish that? Do I really need to do it for like all the feature, all 3 species for all 3 like columns? Well, actually, that's not a bad thing if you write it in the right way. Anyone? So one way we can run this is by using the z-score, is using the transform function and group by. So what group by is doing is that it's trying to create an aggregate value for that thing. So let's see one example of that. Do I still have my df loaded? Yes. So one way I can do this is basically doing it starting with a group by transformation. So for my sepal length, z score, I can try to do it this way. It's already telling me with autocomplete. Surprised. Because I've typed it before, probably. So this transform function is taking a lambda expression. What is this lambda doing? Well, it will take whatever is segregated by the species, and so x is whatever segregated by the species. Now, so x is a pandas series. Okay, so pandas series, if it's Aristatosa, for example, the first one is Aristatosa, then this x is all the data with Aristatosa with sepal length. Okay, And then it's going to do this operation to create my z-score here. And then I can run this operation for 3 times. Sample with Cn z-score. I think it's going to auto-complete it a lot for me. Species. Similar, did I spell it wrong? Yes. Ooh, should be with Cn. Yes. And then my set pedal, and then the final thing, pedal with Cn is equal to df. If I do it 4 times, ultimately I will have it. Okay. Alternatively, you can also create functions to do this. Create z-score and do this with this vectorized operation here. So 2 different methods. So let me see. That is sepal C. Okay. You can create the same thing with this string concatenation method. Then this will work. And then run this function for I in df.callName. Well, I already have that, so I can't really run it now because otherwise it will create a z-score of z-score, which is complete nonsense. Second, yes, it's complete nonsense. Okay, this is a very common operation called normalization in data science. Why do I need to do that? Because now I can have a ground to compare the different to compare the features across each of them. Because previously pedaling, well, the pedaling is in the range, pedaling and sepal. Well, if one of the data is in a range of 1 to 10, and one of the data is in a range of 1 to 1,000, how can I compare these 2 features logically? I mean, does 8 really means a large data? Does 700 really means a large data? Can I really make a meaningful comparison? The answer is no. So we use z-score and normalization to compare that. So something with a larger z-score really means that it's further away from the center of distribution, from this average value. For example, it's kind of like, okay, your math score is 60, but your, let's say, English score is 80. Does that mean you're better in English than in math? What if the math class average is just 20 and you got a 60? Well, that probably means you're doing really good in that class, right? And what if your English class average is 90 and your score is 80? That probably you're still like a little bit below average, you want to catch up a little bit. So this is what z-score allows us to compare. I'm not going into further details for z-score and so on, but if you're interested, trying to see what's happening here, z-score, standard deviation, normalization, there are common topics in like statistics. Okay, I think that's all the materials I have for today. Thank you guys for coming. Feel free to let me know and ask me if you have any questions from homework, about pandas, about like Python in general. I'll hang around here for a couple more minutes. Yeah, feel free to give me any questions. And again, thanks for coming. Feel free to let me know if you have any questions from homework, about pandas, about Python. I'll hang here for a couple of minutes. Yep. Do you have any question on me?
Yes, hello. So this is my first time in this class,
Okay.
and I was trying to do the homework for this week.
Okay.
I I was not familiar with pandas beforehand. So while
Okay.
going at a few cleaning up exercises for the last few tasks, um,
Yes.
I sometimes saw this pattern that we get a column from a data
Yes.
frame
Yes.
and we replace it. Like, let's say we want to clean up a column. Let's say we have an age column that has a bunch of useless data, and we want to convert all the data into a number. And
Okay.
so we get like some kind of variable, and we put the column from the data frame into that variable, and then
Okay.
we modify that variable, and then we write that series back into the data frame. So that's one pattern I saw. Another pattern I saw while looking at the documentation was we call like pandas dot transform, and then we give it a column and like a new like a function that takes the data and then gives back another data,
Yes.
and then we set in like in place equals true. So
Correct.
uh, I'm kind of like confused, like where we should use each pattern and what's a good best practice for when we are modifying some kind of column in place.
I would say it's a personal preference. There's no like industry standard of like, oh, you should definitely do create a new variable and assign it back and assign it back, or just do the transform and in place. The only pitfall is that I think, in my opinion, like I think you were saying something like, let me just read a data frame to make sure I'm getting what you're saying is right. For example, if I want to do like df of sepal length, new sepal length maybe, new column is equal to sepal length, something like this, or like new column, something like, or okay, if I want to modify my original sepal length, for example, +5, and is that what you're referring to as the first method?
Yeah, something like this. Or uh like I also saw that sometimes instead of like using a temp variable, you just
Okay,
modify it in one line. You just say, um, for example,
df of sepal length.
yeah, something like you just like you modify it without even assigning it to anything.
That's acceptable, yes. I think this is a more common method to do than assigning a new variable. You only assign a new variable usually, well, usually we'll assign a new variable for intermediate transformation because some of the transformation could be a little bit tricky to get in one line. Or I didn't quite cover this, but actually using we usually like do not like to use transform that much because transform is not a vectorized operation, put it that way.
What is
If you
transform?
like this method here, I didn't
Mm.
quite cover this, but transform is not a vectorized operation. Transform or apply is not a vectorized operation per se. You would, in principle, if you're really concerned about performance, you should always stick with this type of operation. And another thing is that, oh, for example, of let's say that transform and then in place equals to true. Is that what you're saying?
Yeah.
I think the first one is better than the second one in this particular case. First, it's more readable. Second, you would using lambda is not a good practice in pandas, put it that way, for performance issue.
I got a question. What is the difference between transform and apply? Because I've been using
Apply.
dot apply, and I don't know like what is the difference.
I think it doesn't really, for some specific case, it doesn't really give me, it's not supposed to happen this way. Transform and apply. Good question. I think one of them only works when you're using group by. The other one works for whatever functions you want, basically. Let me double check. Let me double check in a second. Hold up.
I have another question. So
Okay.
let's say that we want to write a function that modifies a column
Yes.
in a data frame, and we pass that function a data frame. If we don't return that data frame back, is the copy of that data frame in the function gonna replace the original data frame values?
Depends. It depends on if you're using an in-place method or not.
Oh, I don't think, no, like let's say you just pass the data frame to a function and then you just say this column of this function is now, this column of this data frame is now the same +5, and then you don't return it.
I think it will not go back to the original value.
Oh, I see.
This is actually a very common mistake.
Yeah,
If
so
you do not return
I've been
anything.
trying to do everything like every task in a specific function,
Yes.
and the result would be, oh, I gotta return the data frame after it's modified again. And
Yes.
then that experience with like um pass by value, but not by reference,
Yes.
along with the fact that we are modifying the object itself. When we get the column, we can just like replace it on the spot, and it would just run some operations. That's very, very convenient. But like I'm coming from like a more like a strong typing language kind of background, and it's just like messing with my brain a lot. It's like, hey, what is happening? What is the value of this thing that we're returning? What is going on?
Unfortunately, this is one of the feature in Python. It's, yeah. If you want though, you can try to convert, you can use import typing and like make it a little bit. There's a typing support in Python after 3.9 so that you can enforce like, if you enforce typing, then you can def your function, like my function, and then like input df, you can do something like this to specify, to give it a template, if that's what you are more used to. That would work. And if it's not returning anything, then you will give it a none and something like that. If that's what you're more familiar with, you can certainly do it this way. That being said, it's not like it. It does depends on like whoever is writing the code. Like some people prefer writing code in this way, some people don't. So
I see. Well, thanks a lot for all the great answers, and
yeah,
really thankful for the amazing talk.
yeah. Oh, I do have. I think I got the answer for the apply versus transform. So apply will give you a row by row operation, whereas transform is a little bit more vectorized, put it that way. So what behind the hood, what transform is doing, what apply is doing is that it is applying that function to like, for example, you're calling a function to, let's say you're calling df.apply, let's say lambda x of, let's say sepal length plus sepal width, x of sepal width, petal width, or whatever. What under the hood, what it's doing is that it's doing row by row. Let's say df.new is equal to this. This is pseudocoding. What under the hood is doing like adding this two and create one row by row. It's definitely not a vectorized operation. On the other hand, transform does support part of the like vectorized operation, but it's not like it's still a little bit different than a pure vectorized operation. Put it that way.
When you say vectorized, do you mean like it's using the GPU to handle the operation?
Not exactly using GPU, but similar concept. What we refer to vectorized operation is that you're treating the entire column. You're doing an operation for this entire column as a vector. And that's what we call a vectorized operation. For example, this is what we call a vectorized operation. I mean, you can try to run this and you will see a time. I think you should be able to see a time difference. You should be able to see a time difference between this operation, between these two cells. Just because this one is a vectorized operation, this one is not. You can run it and see. It's not supposed to, I'm not supposed to write it this way, but anyway. You should see a performance difference between using apply and this method, because apply is a row-based operation. It's doing the operation row by row, whereas, well, it's actually very similar for this one. Doesn't really matter, I guess. Yeah, it doesn't really matter for small data sets, but for a larger data set, it will. This one is a vectorized operation and this one is not. And also this timing method depends on like your Jupyter setup as well. So it's not the most accurate thing. It only has a small tiny difference for small data sets, but for a larger data set, it will have a difference. This one is giving it a row-based operation, or yeah. So that's the major difference. Refrain from using apply as much as possible, put it that way.
Okay, thank you a lot, and I see you next week.
Yeah, see you next week. Do you have any question, Amir?
No, that's it. Thank you.
Okay.